Uh, Thank you. I got my PhD a little bit earlier, like in 2008, and I spent this time between 2008 and 2016 when we founded the company building actually recommender systems like Amazon, which you've seen on the previous slide. And I'll be talking, my goal here is to explain why does it matter to evaluate neural-machine translation, and how to do that in a practical way, not as a like research study, but actually to apply on real-life projects to optimize ROI on these projects. And I will also show you some nice infographics and data visualizations, but I have a different disclaimer than previous speaker. I removed all brand names from these comparison charts to avoid you jumping to conclusions, because results are very project specific. If you want details, you may find those reports online, some of them, and read all those nuances about these specific systems we evaluated. And I also want to start with small surveys. So who use MT in production, meaning use it and get benefits from that? Can you raise your hands? Cool. And how many of you use NMT, neural machine translation? How many of you use custom neural machine translation? Good. And how many of you track post-editing productivity, meaning how many exact, like 0 edits and what time spent on editing this MT output? Cool. That's really nice. So I'll touch that. And today it's a very interesting time to start applying machine translation or continue applying it at a new level. Because, you know, NMT emerged mostly in 2016 when Google was able to collect enough computational power and data to train this large big model which you could use to make it affordable. But the biggest problem was that it was too hard to let you customize this model, too expensive. If the whole Google was able to train this single model only in 2016, no way you can customize it for a small project, right? And this year, or most likely last year, and most likely last summer, we have seen this technology came to a new level when you can actually customize this big model for your small project. And that's what I call here domain-adaptive machine translation. And compared to, you know, NMT, custom NMT, which we built from scratch, here you can use a little bit of data, as low as 1,000 parallel segments. And you give this data to this NMT like to sniff, like you give cloth to a dog to sniff in movies, you know. Because it's sort of, this system have seen all the data in the world, but the problem doesn't have context of your project, so you need to give this, like here's my project, you see? And another important thing, that for custom NMT, the main cost driver is a linguistic effort. Because you have to hire a team of computational linguists who will clean your data, align your data, calibrate this engine. And in this technology, most of that is automatic. That's why the main cost driver is electricity. And you pay not tens of $1,000 just to try, you pay from tens to hundreds to try, which is super cool. And based only on marketing materials, because I have lots of NDAs with those companies, that's when those systems were launched. So I think first was Globalis, and they switched to NMT in September 2017. Then Lilt, then everyone else. Systran, Microsoft, IBM, SDL, Modern MT, and Google. Many of those systems are still in beta, but still they're already used commercially by many companies and deliver nice results. And first question I want to touch is why to evaluate them? So overall, as Cornelia mentioned, well, we provide like MT brokerage solutions where you send your data, and based on the language pair, we route to the best engine today. And to do that, we evaluated lots of stock MT engines, pre-trained. And there we've seen, yes, indeed, for most popular language pairs, you need to use around 9 different engines, and that changes fast. But the question was, is it the same for domain adaptive engines? Because maybe when you give your data, yes, baseline models are different, but maybe on your data they train to the same good level, and there's no point in evaluating them. And frankly, that was the answer we got from some of the vendors, like, don't evaluate our system, it's good. All systems are similar, but we decided to check that, right? And we ran first study in November 2018, when most of those systems went into sort of public beta. And we found that actually you should evaluate them, because those baseline models are different in different languages. They're also different by domain, and also there's new dimension of difference related to learning curves. How fast those models improve over the amount of data you have. And by the end of the day, if you make the right choice, you can significantly increase, you can significantly increase the amount of perfect segments for a project, segments which are not touched by a post editor, and significantly decrease amount of critical issues where MT output shouldn't be used, it should be translated from scratch. I will describe that in more detail later, but basically that's a good all-around stock NMT, which many of you use. That's the best stock NMT for this project, that's the best custom NMT, and if you manage to combine them in your workflow, then you get even better. So, the first question when you want to select the MT engine, which of those 30 plus engines you should evaluate? Which of them suit your project? And first step typically is selecting candidate engines based on the project attributes and business attributes. So project attributes are obviously language pair support, and domain adaptive NMT has much narrower support. It's not thousands of language pairs, hundreds. It's typically pairs with the English language in either side. And also, many of them do not distinguish dialects. So if you need, Canadian versus French, Portuguese versus Brazilian, Castilian versus Mexican, you have to check by yourself what's in the baseline. Then domain, some of the systems like Microsoft, they provide domain-specific baseline engines, which you also may take advantage of. Availability of reference data for automatic scoring, and this should be high-quality data because it's your gold standard, and availability and volume of training data. And in the perfect world of machine learning, what you do, you take your training data and you extract part of that as a reference data, which in real life doesn't work, because your real life translation memory is not that high quality. You have mistranslations, fragments, misalignment, and all those things which you can't tolerate having in the training data because of all those automatic data cleaning procedures, but you cannot have it in your reference data because your results will be skewed and biased. And then availability of glossary, because some of the domain adaptive engines, they support glossary adaptation. Then business requirements, what data protection level you need. Are you fine with data confidentiality, or you need no trace? Or maybe you're happy to share your data with the MT vendor to let other clients benefit from that. Maybe. Then data locality requirements, which I think should be a thing in Germany, right? If you use your client's data, personal data, you cannot really process that in the United States, I guess. And across the world, there are 15 different data locality regions. So if you're a global company, you should think about that, like risk. Then contracting requirements, because in some cases, especially in case of Chinese and Korean engines like Naver, you should have entity in this country to have a contract with them. Then deployment requirements. Are you fine with public cloud or private cloud or on-prem? And finally, user scenario. how much are you going to translate per year, what's your expected peak load, and how often you're going to retrain and update your engines. So that tools leaves you typically with like 10 to 15 engines to evaluate, and out of them around 5 will be domain adaptive as of today. And then you need to run MT quality evaluation. There are two approaches, you'll know. One of them is a linguistic assessment, which is very good in terms that you get absolute level of quality, you don't need reference data, but it's super expensive and slow. So like 2,000 segments, 10 engines, 20,000 segments to evaluate with humans, lots of money, lots of time, and by the moment you'll be over, technology will change. So you'll have to re-evaluate. Good. Then reference-based scores, they're quick, cheap, and dirty, and you can get statistically significant results, but it's just proximity from human translation, one of options of human translation, and it's clear that for domain-specific projects, it's not enough, because you can hardly embed subject matter expertise into this automatic scores. So we found a way to combine that. What we do, we run automatic scores on scale, and then we use sentence-level scores as a magnifying glass for linguists to focus on specifically part of this reference data which requires human attention. And it enables you to reduce amount of effort around 200 times for this LK, making it affordable for real-life projects, and that's what I'm gonna explain, how we do that today. So first, automatic scores. Sorry. So there are many of them. I can talk hours about that. But the main difference is either sentence level or corpus level, and other oriented on recall, meaning additions, or precision, meaning omissions. So we use corpus level scores, Sacre Bleu, Blue, Rouge, Ribes, to evaluate engines on corporal level, and we use Lipur as a working horse, as a sentence level score which combines recall and precision for this deep evaluation. And how does it work typically? So using sentence level scores enables us to analyze confidence intervals when we run this scoring, and we make sure that we have enough data in reference data set to avoid this intervals overlap. You may see that like here you can hardly judge any conclusions because you have no confidence in them. You have to have at least like 1,500 segments. Then we'll look at corpus level metrics to put all candidate engines in two buckets, good candidates and bad candidates. And one thing we also look for, how those corporal level scores, like Lipur, Blue, Rouge, how they're correlated. Because typically they are correlated. If there's miscorrelation, given the nature of the scores, it highlights specific type of problems. So then, when we identify those top runners, there typically no statistical significant difference between them. So they all go to human judgment. And then we apply our magnifying glass. So what we do, we pick all segments in this reference data set. And we, for every segment, we'll look at the mean average score across all engines, and we'll look at the standard deviation, meaning how different engines scored this segment. Are they translated this segment equally bad or equally good, or they're translated it differently? And we'll look at two specific subsamples. One subsample is bad segments. Segments translated bad by mostly all engines. That's typically mistakes in reference data, misalignments, mistranslations. Sometimes you have to decide. Sometimes it may be heavy localized translation, very creative, and you have to decide, do you really require that? Or it's a problem of your old style guide, and you actually may drop that. If you require that, make sure that you have it in your training data, because if you don't, then this training will be useless. But the main thing we look at is segments which are sort of median, meaning that they are that's what you will have using this engine in production in terms of proximity to human translation, but in the same time, they're translated differently by different engines. So they sort of emphasize this difference. And for these segments, we run human judgments, which can be of two types. It may be sort of a priori evaluation, LQA, like MQM, DKF scale, and so on. Or it may be estimation of the actual post-editing effort when you just ask people to post-edit that and measure certain metrics. So we started from human LQA, and we worked with one LSP, which has very clear simplified version of MQM, DQF for LQA projects with Logros IT. But what we found is that this LQA scale is not very good for evaluating MT, because specifically people are very opinionated in terms of the error severity. And when you take these human results, they're very unstable based on if this reviewer decided it's a big problem or not so big problem. So we decided to use different scale for that. 4 buckets. 1, it can be used without any edits. 2, second is it may be light post-editing, like target-only post-editing. 3, it's full post-editing, meaning source target post-editing. And 4, you should not use this MT output. And latter is the case specifically, for example, for medicine. And those are results for English to German medicine. So for medicine, that's the case when there is some critical medical mistake in this translation which may mislead post-editor. So you should remove this empty output and ask them to translate from scratch. And we did not stop on that. We decided to check, okay, are good engines good at the same segments, or maybe they're complementary? Maybe some segments better take from one engine and others from another. And that's exactly what we found. For example, you may see that here, this engine is much worse at these segments, but it's better on others. And typically that's the case when you have one engine is good customized engine, which doesn't have as much terminology errors, but another one is very good linguistically, stock engine, which is very good linguistically at this language. Like for German, it's DeepL today. For a good customizable engine for German is Google AutoML. So it happens that you may take, for terminology heavy sentences, you take translations from AutoML, and then if it's a common sentence without terminology, you take translation from DeepL. If you may set up workflow this way, so that it's convenient to do that, then it will work. Yeah, and you get even better impact, significantly reducing number of critical segments. Then another approach is to estimate direct post-editing effort. And we do that with some of the clients, and the results are very surprising. It may turn out that, well, it's typically what we see, that from customized NMT, there are more accurate translations, but if that translation should be edited, it's typically much faster to edit good stock engine, because it's just linguistically more fluent, and it's easier to make those edits. And it might be 4 times easier. Yeah, there are some other dimensions related to total cost of ownership, because they all have different business models. Sometimes you pay a lot for training, sometimes not. Sometimes you pay much more for translation. Depends on what's your business case. And I just want to remind about these learning curves, which means that in the beginning, when you have a little bit of your post-edited data, you may use one engine, but after you got more, you may use another one. So conclusions. NMT engines are different, even if you customize them. And the right NMT choice may drive ROI significantly. You may get significant impact on how much you spent on post-editing. And the way to use this evaluation in real-life projects is to just clever combine automatic scoring and human LK. All those approaches and reports are public, fully transparent. You may just take it and use it. And that's what I would recommend to do. Yeah, thank you.
Spasiba. Very good. So this was interesting. And I think there'll be some questions. And before we start, I have one that I thought there was a sort of something you didn't touch on. What happens if the NMT solution I'm evaluating comes away with, for my language pair and my domain, as the best one, but it doesn't really fit into my TMS? What then?
Yeah, it's a very good question, because TMS systems typically take a long time to integrate new engines, and probably you can, in case of, for example, Google OTML, maybe in MemSource, you have native connector from recently, but the engine is out there for half a year. So, well, that's actually what we help to fix with our middleware, because we have connectors like for MemaQ, Trados, where you can use all the engines. That's why I'm sort of urging you to evaluate and find the best one for you, because probably it will be different from your default.
Thank you. Other questions? Yes, here we go. All right. And you realize, people, in 10 minutes there's lunch, so okay. Here we go.
It will be quick. Thank you, Konstantin. You said that good engines don't make the same mistakes. To paraphrase that correctly, why is that? If the data are the same, assuming they are. Is that answerable, or is it too tough a question?
Is the question clear to everybody?
You said that you asked, do good engines make mistakes in the same sentences? And my assumption, or my gut would say, well, yeah, stands to reason, but you have a clear finding that it is not the case. Now I have an assumption that I'm taking the same data to train these engines. So why is that the result?
Good question. All right.
Yeah, so we typically see this difference between customizable engines and stock engines, because stock engine may be very good at this language pair, because the creators of this engine built unique high-quality data set like DeepL with Lingy, right? But they don't have customization option. So this engine is the best linguistically, but you can customize it, meaning if you use it, you still have lots of terminology errors for your specific project. And then you pick linguistically worse baseline model, but you adjust it with your terminology. So you have less terminology errors from this customized NMT, but more linguistic errors. And since sentences in a project are different, some have more terminology, others have less terminology. Depending on how common is the sentence, you would prefer to pick one of the engines. However, I must say it's very tricky to set up this workflow with multiple MT engines. You have to do some workarounds with translation memories to ingest it in the TMS system. But if you succeed, you will like it.
One more question here. Anybody else have a question? No, everybody else is just hungry. Okay, and Konstantin is going to ask Konstantin.
As Konstantin to Konstantin, what do you think about predictive quality evaluation, which is built into NMT toolkits? And if you could expand on this, what do you think about predictive quality evaluation prospects in general?
As Konstantin to Konstantin, it will be a very frank answer. I cannot lie myself. Look, there's no magic around evaluation. Evaluation is always comparing to some reference. There's no evaluation in vacuum. So when you run predictive evaluation, you always have some underlying benchmark you use to run this evaluation. Like what I showed in the beginning, we have for stock engines. It may be used as a predictive evaluation. If you have this language pair, that's the engine you should use. Most likely, we predict that. But it's based on a specific general purpose benchmarks. So if you have enough in-domain data, you may also predict which engine is the best for this domain today. But the problem is that you should make sure that this benchmark was run recently. Because if it's like, for example, historical TM data, you may got this data for this domain half a year ago and it's irrelevant. So we'll rely on this predictive analytics and overlook the recent very good engine. That's my answer. So if you have a way to have in-domain, regular updated benchmark, yes, you can predict based on this benchmark.
All right, if we don't, do we have other questions? No, we don't. So I want to thank all the great presenters on this track, Anton, Steve, and last but not least, Konstantin. And thank you all for being such a well-informed and kind audience. We wish you a nice lunch and a good rest of the day. Thank you so much.